morning everyone. In this video we are going to talk about matrices, inverse of a matrix. The question reads, given the matrices A 2, -1, -3, 1 and B -3, 4, -2, -1 and that C is equal to A squared minus B, write down the inverse of C. So in this question, we are first of all going to determine the value of C. Remember, we are given A and B. So from this equation here, we'll determine C and then proceed on to get its inverse. So the equation here is C is equal to A squared minus B. Therefore, in order to determine C, we are simply going to substitute these matrices we are given. So A squared means we multiply matrix A by itself. That is 2, -1, -3, 1 times 2, -1, -3, 1. And then after that, we subtract B, so minus matrix B, and matrix B is -3, 4, -2, -1. So we are going to multiply these two, and we are going to multiply the first row in this first matrix, first row by every column in the second matrix. So we'll have 2 by 2 plus -1 by -3. So 2 by 2 is 4, -1 by -3 is 3. When we add, we get 7. So it takes the position of this. Remember, these are 2 by 2 matrix, just as the two matrices are. So once we are done with the first column, we are going to multiply the first row again by the second column. 2 by -1 is -2, -1 by 1, that is -1. So -2 plus -1, that is -3. And then once we are done with the first row, now let's move to the second row. We're done with the first row, we are now looking at the second row. Second row again multiplies every column in the second matrix, just the same way we did for the first one. -3 by -2, that is -6. 1 by -3 is -3. When we add, we get -9. Again, -3 by -1, that is +3. 1 by 1 is 1. 3 plus 1, that is 4. Once we are done with that multiplication, we subtract the second part, just as we have in the equation. So we have here -3, 4, -2, -1. Subtracting, we are going to have element 7 corresponds to element -3. So we subtract the corresponding elements. 7 minus -3, that is 7 minus -3. That gives us addition, so that is 10. We also look at this one, -3 minus 4, that is -7. So that is the position. And then coming down here, -9 minus -2, that is -9 plus 2, which is -7. And then here we have 4 minus -1, so that is 4 plus 1, which is 5. So this becomes matrix C. After determining matrix C, the next thing is to determine its inverse. So the inverse of matrix C is obtained as 1 over the determinant of matrix C times, now considering the elements of the leading diagonal is this one, that is of matrix C, we'll have them swapping position, so 5 will come to the place of 10 and 10 will come down. So here we have 5 and then here 10. And then for the second diagonal, we are going to negate them. So because they are negative, we make them positive. So this is 7 and here also 7. And once you're done with this, the next thing to determine is the determinant of C. So determinant of C is obtained as, so back to matrix C, we'll have the product of elements in the leading diagonal, that is 10 by 5, which is 50, minus the product of elements in the second diagonal, that is negative 7 by negative 7. The second diagonal is this one. So negative 7 by negative 7 is 49. So getting the difference, that is 1. So substituting here, we'll have the inverse of C is equal to 1 over the determinant, which is 1, times 5, 7, 7, 10. And this finally simplifies to 5, 7, 7, 10. And this is the inverse of matrix C as had been desired. Now, this marks the end of the solution to this problem. I want to thank you for watching. Hope to see you in the next video. Bye.